Okay, so this is our first lesson on trigonometry. Trigonometry is the study of triangle measurements, so we're talking about angles and side lengths. So in a right triangle, you all know that the hypotenuse is the longest side and it's across from the right angle. The other two sides are called the legs, and when we're talking about trigonometry, we have specific names for the legs. So when we name them, it's always in relation to whichever angle we're talking about. So we might be talking about this angle up here, or we might be talking about this angle over here. Either way, it's whichever one we're talking about determines the names of the sides that we're talking about as well. So this symbol in red here is called theta. It's a Greek letter, and it's used to denote an angle. So if we're talking about the first one over here, the adjacent side is whichever one is touching it. So that would be this side over here. So adjacent is the one touching the angle. If we're talking about this angle over here, this side is then adjacent because it's the one touching. Back at the first triangle, the opposite side would be this one over here. And it's denoted O. It's the one that doesn't touch the angle. In this triangle, here's side O. It's opposite to the angle theta, and it's not touching it. In both triangles, it doesn't matter which angle we're talking about, the hypotenuse is always across from the right angle. That doesn't change. And it's always the longest side. Okay? So the tangent ratio, which is actually really important, it's used to solve all the problems here, is basically that the tangent of whatever angle we're talking about, theta, is equal to the length of the opposite side over the length of the adjacent side. Okay, so the formula we use is tan for tangent theta, which is basically 0 with a line through the middle, is equal to O for opposite over A for adjacent. So this is the formula you need to know and remember. This is the one we'll be using in the next couple of equations and examples. Okay, so steps to finding an angle theta. If you're given some side lengths on a right triangle and you need to figure out one of the angles inside the triangle, this is how you do it. So step 1, you identify the hypotenuse, the opposite side, and the adjacent side to whichever angle theta you're talking about. Step 2, you determine the tangent ratio. So that's where you write down your formula and you start plugging in whatever numbers that you know. And step 3, you solve for theta. So here's an example of this. So step 1, identify the hypotenuse, opposite, and adjacent sides. Well, here's theta, so that means that this is our adjacent side, this is our opposite side, and this is our hypotenuse. Okay, so step 2, we write tan theta equals O over A. That was the formula we had a couple slides back. That's our tangent ratio. The only things we know at this point are the lengths of the opposite and the adjacent side. So we can plug those in. So tangent of theta equals opposite over here is 14. Adjacent was 29. And now we're going to solve for theta. So the easiest way to think about this is to consider the tangent of theta like multiplying something by theta. So when you rearrange something that you're multiplying, actually let me, erase that part. Okay, I'll write it this way. So theta is equal to 14 over 29, and since we are multiplying tangent over here, and you would divide by the tangent over here, and you would also divide by the tangent over here. Okay? Cross these things out, and you have this thing that eventually will look like this. So theta is equal to this. We rewrite as the inverse tangent, which is tangent with an exponent minus 1 up there. And then we have 14 over 29. Okay? This part is just to show you how to do it. You don't have to write this down every single time. So I'm going to start this again and show you what you should write down. Tangent of theta is equal to the opposite side over the adjacent side. Plug in our numbers here. Tan theta equals, we had 14 over 29. And remember, we've already labeled H, O, and A over here based on our theta here. So theta is equal to the inverse tangent of 14 divided by 29. Once you put that into your calculator and solve, you'll end up finding out that theta is approximately equal to 26 degrees. One thing to note is to make sure your calculator is set to degrees. It should have a D or a DEG somewhere on the screen to show that it's degrees. The other options are gradients and radians. And that would have either GRAD or RAD or a G or an R. If it's not set to degrees, you will get the wrong answer at this point. So when you're doing trig, always make sure that it's set the right way. Okay, so on your calculator, when you're trying to solve one of these things, we had theta equals inverse tangent of 14 over 29. That was our equation. There usually isn't a button on a calculator that looks like this until you push either a shift button or a second function button. So usually it'll look like this. You hit second function, then you hit tangent, and that will bring this up on the screen for you. Then you put your others in brackets. So 14, bracket 14 divided by 29, close your bracket, hit equals, and that's where you should see your answer, which rounded gave us 26 degrees. Okay, so this is the important part to know here. How to do this on a calculator. Okay, if you're given an angle and a side length and you're trying to figure out the other side length, here's how we do it. Step 1 is the same. You identify the hypotenuse, the opposite side, and the adjacent side to the angle that you know, which is theta. Step 2, you write down your formula and you start plugging in your numbers, and then you solve for the unknown side, step 3. So here's an example. We're given an angle, 47 degrees. Oops. We're given 47 degrees. We're given a side length, and we're looking for the length of side A. So step 1, just like before, we write tangent to theta equals O over A. Start plugging in some numbers. This time we know theta is 47 degrees. Oh, I forgot step 1, didn't I? So identify the hypotenuse, identify the adjacent side, identify the opposite side. So hypotenuse is always a long one across from the right angle. The adjacent side is touching our 47 degrees, and the opposite side is the other one that's left. So tan theta equals O over A. Tangent of 47 degrees equals O, which is side A, the one we're looking for, over side A, the adjacent side, which is 25 point, wow, this stylus is terrible, 0.9. Let's try that again. $25.9. Yikes, I need a new stylus. Okay, rearrange this. We have something here is equal to a fraction on the right side. So we're going to multiply both sides by 25.9. So we end up with 25.9 times the tangent of 47 degrees is equal to side A. Once you plug that into your calculator, you should get that A is approximately equal to, let's do this, 9 times 10, 47. So we get about 27.8. 27.8. And in this case it's centimeters. Okay? To put that in your calculator, it's a little easier than the other step. There's no second function to worry about. You just type in your number, 25.9, and you multiply by tangent of 47. Again, make sure your calculator's in degrees, and then you hit equals. This one's a much simpler step. 27.8 centimeters was our answer. If you were given a triangle where you knew 47, you knew this side, 27.8, and you're looking for this side, you would do the same thing except rearrange the other way to solve for your unknown side. So just like rearranging any other sort of equation, multiply and divide as appropriate. Okay, so hopefully that has explained things fairly clearly and you understand what to do with your tangent ratios.